Hello everyone! Welcome to an exciting episode of Math Explained Simply. Today, we're diving into the world of interest, specifically, interest compounded continuously. Don't worry, we'll break it down into bite-sized pieces so that even if you're not a math whiz, you can understand it. Alright, let's start with the basics. Compound interest. Imagine you invest some money, and over time, you earn interest not just on your initial amount but also on the interest that accumulates. This process happens at specific intervals, like monthly or annually. Let's consider a simple example of compound interest. Suppose you lend $1,000 to a friend at an annual interest rate of 5%. This means that at the end of the year, you will earn 5% interest on your initial deposit. In the first year, your interest would be $1,000 times 0.05 equals $50, and your total savings would be $1,000 plus $50 equals $1,050. Now, compound interest comes into play in the following years. In the second year, you don't just earn interest on your initial deposit, but also on the interest you earned in the first year. So, in the second year, you earn 5% interest on $1,050 instead of just $1,000. This means your interest for the second year is $1,050 asterisk 0.05 equals $52.50. Adding this to your total savings, you now have $1,050 plus $52.50 equals $1,102.50. As you can see, compound interest allows your savings to grow faster over time because you're earning interest not only on the initial amount but also on the interest that accumulates each year. But what if I told you that there's an even more effective way to grow your money? That's right, I'm talking about interest compounded continuously. Compounding interest continuously is a bit different from compounding interest annually or periodically. In continuous compounding, the interest is calculated and added to the principal an infinite number of times throughout the year. Let's try to understand it with a simple example. Imagine you have a magical penny that doubles every second. If you start with 1 penny and it doubles continuously, after 1 second, you have 2 pennies. After 2 seconds, you have 4 pennies, and so on. Continuous compounding in finance is a bit like that magic penny scenario. Instead of doubling every second, your money grows continuously over time, thanks to the constant addition of a little bit of interest. Continuous compounding is like the magic of constant, non-stop growth, just as our magic penny doubles continuously. It showcases the power of compounding when it happens all the time, even if just a little bit. The formula for continuous compounding is given by A equals P asterisk E caret RT, where A is the future value of the investment, loan, including interest. P is the principal amount, the initial amount of money. E is the mathematical constant, approximately equal to 2.71828. R is the annual interest rate, in decimal form. T is the time the money is invested or borrowed for, in years. Let's take that above example again, where principal equals $1,000, rate equals 5% compounded annually, and time equals 2 years. Then, by the formula, A equals 1,000 asterisk E caret 0.052. E caret 0.052 is roughly equal to E caret 0.1. And when you calculate this, you get around 1.105170918808. So, A equals 1,000 asterisk 1.105170918808, which is approximately $1,105.17. After 2 years, with continuous compounding at a 5% interest rate, your investment would grow to approximately $1,105.17. The key difference between compound interest and interest compounded continuously lies in the frequency of compounding. With compound interest, we have specific compounding periods, but with continuous compounding, it's like having an infinite number of compounding moments. In the above example, when a $1,000 principal is compounded annually at a 5% interest rate for 2 years, the final amount with compound interest is $1,102.50, while with interest compounded continuously, it reaches to $1,105.17. The difference of $2.97 illustrates the impact of continuous compounding. Although this difference may appear small, it becomes more significant over time. The longer you keep your money invested, the more noticeable and substantial the returns from continuous compounding become. So, in a nutshell, compound interest and interest compounded continuously are like cousins. They both involve earning interest on interest, but the continuous compounding takes it to the next level with an infinite number of compounding moments.